In this lesson, we're going to learn how to write equations of lines. This is the third in a four-part series on this topic. In this video, we're going to focus on how to write the point-slope form of a line when given a graph. Let's start by exploring what exactly point-slope form is. In order to write the equation of a line using the point-slope form, we need two things. First of all, we need any point on the line. We'll call that point x1 and y1. We also need the slope of the line. Once we have those two things, we're ready to write our equation. We use the formula y minus y1 equals m times x minus x1, which might look like an unusual equation, but is really nothing different than the slope formula with the denominator cleared. In this formula, the m represents the slope of the line. The x1 and the y1 represent any point on the line, and it doesn't matter which point you choose. In our first example today, we'll take a look at several different ways you can write the line's equation by using different points. Here's our first exercise today. Write an equation for the line shown on the graph in point-slope form. Because we're writing our equation in point-slope form, we know we're using y minus y1 equals m times x minus x1. We need the slope and a point from the graph, and we have many points to choose from. We start by counting the movement from point to point to determine the slope. The slope of this line is 1 over 2, or 1/2. And then the point, well, we have a lot of choices. Let's suppose we choose the point 0, negative 3. If we use that point, then the 0 is our x1 and negative 3 is our y1. We substitute these numbers into the formula. Y minus y1 is y minus negative 3 equals m 1/2 times, in parentheses, x minus x1, which is x minus 0. We always need to simplify things where possible, and I notice on the left-hand side I have a double negative, y minus negative 3. A double negative is a positive, so our equation is y plus 3 equals 1/2 times x minus 0. This is the point-slope form of the line. We'll hang on to that down in the corner here because I want you to compare that to what happens when we choose some other points. For example, suppose instead of the point 0, negative 3, we chose the point 2, negative 2. In that case, 2 would be x1, and negative 2 would be y1. We substitute into the formula y minus y1, y minus negative 2, equals m 1/2 times x minus x1, which is 2. Again, on the left-hand side, I see a double negative, y minus negative 2, which will be y plus 2, equals 1/2 times x minus 2. This is also the point-slope form of the line, which might feel a bit uncomfortable because now we have two very different equations that represent the same line. But that's okay. These equations are equivalent, and I'll show you what that means in just a couple of minutes. Let's suppose we chose a different point yet. How about the point 4, negative 1? 4 would be x1, and negative 1 would be y1. We use our formula and substitute the values in. Y minus y1, which is y minus negative 1, equals m 1/2 times x minus x1, which is x minus 4. We simplify the left-hand side where we see the double negative, y plus 1, equals 1/2 times x minus 4. We have yet another equation that represents the same line. And let's just choose one more point. How about 6, 0? In that case, 6 would be x1 and 0 would be y1. We'd substitute these numbers into the formula just as we did before. Y minus y1 is y minus 0 equals m 1/2, in parentheses, x minus x1, x minus 6. And there I have the point-slope form of the line. How could it be that I have so many different equations that represent the same line? It almost feels crazy, doesn't it? Well, let's take a look. I told you they're actually equivalent, and I'll demonstrate that. Suppose we decided to rearrange each of these equations and put them into slope-intercept form. In other words, y equals mx plus b. In the first one, I would distribute the 1/2 so that I'd have y plus 3 equals 1/2 x minus 0. And then I'd subtract 3 from both sides. Y equals 1/2 x minus 3. That's the slope-intercept form. In the second equation, y plus 2 equals 1/2 times x minus 2. Again, I distribute the 1/2, so I have y plus 2 equals 1/2 times x minus 1. I subtract the 2 from both sides, and notice once again y equals 1/2 x minus 3. I ended up with the same equation in slope-intercept form. When I do that to the other equations, the same thing happens. All 4 of them rearrange to y equals 1/2 x minus 3, which means all of the equations that I had in point-slope form were actually equivalent. So all 4 of these equations represent the same line. Therefore, when you write the equation in point-slope form, it's important to realize that the equation you get may look different depending on which point you chose. But just because your equation looks different doesn't mean it's not correct. Let's try another example. This one's for you to try. Can you write the equation for the line shown on the graph in point-slope form? Remember, you first have to identify the slope, second, identify any point on the graph, and then write the equation. Please pause the video here and come back when you're ready to compare answers. Let's see how you did. Your equation is going to look different depending on which of the 4 points on the graph you chose. First, we identified the slope, m, as -4/3, or -4/3. Then, you identified one of the 4 red points. You labeled your point as x1, y1, and then you substituted into the equation y minus y1 equals m times x minus x1. We substitute in y minus y1 equals m times x minus x1. Remember to simplify your equation wherever possible, especially where you have double negatives. And then you'll have your equation written in point-slope form. As with the first example, you'll notice we have several different equations written on the bottom of the screen. These equations are equivalent, and they all represent the line that you see on the graph. This is everything you need to know to get started writing equations of lines in point-slope form when given a graph. You can learn more about writing equations of lines in the subsequent parts of this video series. You can also learn more about linear functions in Mr. Dory's Algebra Handbook, available at www.dorypublications.com.